Good Tuesday morning to you all. Hope you're all doing all right. I hope you're enjoying the rain. It's kind of nice to see some moisture out there. And keep working on the limits. That's good stuff. If you have any questions on it, please shoot me an email. I'm around for you, so please do so. Even if just to say, hey, let me know what you're up to outside of our work together. So it's nice to know what you're up to. The next thing we're going to do, or more, I should say, actually, what we're going to continue with is our work with logarithms, because our work with limits and e will pertain to something called a natural logarithm. So we're going to still use our laws of logarithms. And on our last day together, I had you all take 2 pieces of paper, cut out the pieces, and bring them back for our next meeting, which never happened, but you should still have them. They're these things, these triangles. And we're gonna put that puzzle together, similar to the one. What was the shape of it? The other puzzle we did. It was the squares. That's what I meant. That's what I was thinking of. The square puzzles. But still with logarithms. But we're gonna do the same thing with this, because these, as you can see, hopefully, there we go. They're a little more involved, but they're doable. They're possible. They're not impossible. I won't give you anything that's impossible. So without further ado, let's get started. So here are all of our pieces cut out, and I'm going to show you how we can work through them. And the goal, again, is to take these logarithms, solve them for the unknown, and then match up the solution with the equation. So I have this one here, so let's just look at that. So I'm going to write that out.
Log base 2 of 6 plus log base 2 of x plus 2 equals 3.
All right, so let's go ahead and try and unpack this for the unknown x. So let's see. Well, these 2 logarithms are added together, which means we can multiply the arguments together. So I kind of just skipped a step here, but it's basically 6 times x is 6x. 6 times 2 is 12. But it's in the argument of our logarithm. And then, let's see, and then we can rewrite this in exponential form. 2 to the 3rd power is going to equal the argument. Two to the 3rd, well, that's 8. And now we just unpack this for x. So we're going to subtract 12 from both sides. 8 minus 12 is going to give us -4. And then we've got 6x. And then we want to, let's see, divide by 6. So we're going to get x is -4/6. And I'm pretty sure all the solutions will be in simplest form, meaning a fraction that can't be simplified anymore. So both the 4 and the 6 can be divided by 2. So -4/6 is the same thing as -2/3. And let's see if we can find x equals -2/3. Oh, look at that. It's right there on top. Would you look at that? So then you just match those pieces together like so, and there we go. And some of you might be wondering, but Saltham, x is negative, but logarithms can't take a negative argument. That is a very true statement and a valid question. So let's see what we get if we substitute -2/3 back into our original equation. Well, it doesn't affect this log base 2 of 6, but here, log base 2 of -2/3 plus 2, well, this will become positive because -2/3 plus 2 ends up being 1 1/3, which is a positive value, so that checks out. So this will work. Well, you know what? Just for the sake of showing this and clarifying any misconceptions, let's just do this to make sure that this left side is in fact equal to the right side. So again, we're adding them, so we'll multiply the arguments. Rewrite it in exponential form. And we get 24 thirds, which is in fact equal to 8, which is what 2/3 is. Yay! Go us! But you'll notice there's one that says no solution. What might that look like? All right, people, so that's how we work with that logarithm puzzle. So I want you to complete the puzzle, but show the work like we just did here for 11 of them. Why 11? Well, it's a nice prime number. Let's see, in terms of the prime numbers, 2 is prime, 3 is prime, 5 is prime, 7 is prime, and then 11. So it's the 5th prime number. So there we go. So that's why 11. 11 is the 5th prime number. Yeah, we'll do that. And in all seriousness, the point of it is to get you thinking about logarithms and to become familiar with manipulating them as we move forward with our work with this magical number e and natural logarithms. All right. Good luck, my people. As always, shoot me an email if you have questions. Bye-bye. Toodles.